Hello ladies and gentlemen, and welcome to another edition of Mr. Saucedo's Chemistry Class YouTube videos. Today we'll be looking at how to name and write the formulas for covalent compounds, otherwise known as molecular compounds. Okay, so before we start on how to name covalent compounds, we need to review what makes something covalent versus what makes something ionic, because we already talked about ionic compounds. What makes something an ionic compound? Well, remember, ionic compounds have metals associated with them, so you'll always see, cations. Another thing is that they can have polyatomic ions, those ones that we had to memorize, like nitrate, phosphate, sulfate, things like that. What about covalent compounds? They only involve nonmetals. So only nonmetals, sometimes metalloids, but nonmetals are sort of the basis of covalent compounds. Okay? So if you see something and it only has nonmetals in it, it's probably going to be a covalent compound. If you find a metal or you see a polyatomic ion, then that means that it's ionic. Okay? So don't sort of confuse yourself by trying to name an ionic compound using what we're talking about today. Also, don't confuse yourself by trying to push ionic nomenclature on a substance that should be named as a covalent one. So make sure you know the difference between those. The first thing we're going to do, though, is look at the good old flow chart again. Okay? So it says look at the formula of the molecule. If you want to name it, you got to look at the formula of it. And then it says next, does the compound form an acidic solution? What does that mean? That means, does the formula begin with an H? Okay? Or more precisely, does it have the word acid somewhere in it? Okay? As weird as it sounds, yes, when you are naming acids, they have the word acid in them. Okay? That tells you it starts with a hydrogen somewhere. Okay? There are hydrogens that can be sort of donated. If it does have a hydrogen at the beginning of it, if it is an acid, okay, then you have to look and see if there's oxygen present. Okay? If there is no oxygen present, then we use hydro plus the root of the element, ic acid. That's where we get the term hydrochloric acid from. Okay? So hydro blank ic acid, hydrochloric acid. Okay? So, or hydrobromic acid, or hydrosulfuric acid. Okay? If there's no oxygen present, then there has to be hydro put in front. Now, what if there is oxygen present? Well, then we have to look at what anion with oxygen is present. And then in that situation, we're going to name it just blank ic acid. Okay? So if we have a sulfate ion, that would mean that we have sulfuric acid. We shorten the name of the ion and we add ic acid to it. Now you might take a look at the bottom here and see, oh, it also says that, you might have to add us acid. We do not have any ions that you had to memorize that end with an appropriate suffix to make it an us acid. So in our class, for our purposes, you either have hydro blank ic acid or you don't have the hydro. It's just ic acid. Okay? And so all of the ions that we have all end in ate. We have carbonate, we have nitrate, we have sulfate, we have phosphate. Okay? So we can shorten that and then add ic acid to it. That is for acids, and that is where we're going to start off today. Okay? So again, look at the formula. Does it have an H at the beginning of it? That means that it is automatically going to be an acid. Then we have to look and see, does this acid have an oxygen in it? If it doesn't, then we use hydro blank ic acid. If, on the other hand, it does have an oxygen, then we have to drop the ending of the ion and add ic acid to it. Okay, so that's what we're going to start off with. We're going to write the formulas and the names of various acids. So you will need a piece of paper for this, so please take out a piece of paper if you haven't already, because we're going to start with our examples right now. Okay, ladies and gentlemen, so this is our list of acids that we're going to be naming. Okay, and we're going to use the flow chart in order to do so. So we have HNO3, HI, H2S, H2SO4, HF, H3P, and H3PO4. Okay, those are going to be our acids, and we're going to use the naming conventions that we just talked about. Okay, so first things first, go through the flow chart. Are these acids? They all start with H, they all form acidic solutions. Then I have to look at whether or not they have oxygen. So, does the first one have an oxygen in it somewhere? Yes, it does. That means that I'm going to name it as something ic acid. That's when it becomes important to know your polyatomic ions. What is NO3? It's nitrate. So, I have to drop the ending. I have to drop the 8, and then I can plug that into the blank. So that becomes nitric acid as a result. Nitric acid. Next one, HI. Okay, that has no oxygen, so it's going to start off with hydro something ic acid. What element is I? That's iodine. I have to drop the ending to shorten it, and so I get hydroiodic acid. I can drop that completely. Okay? H2S. Again, there's no oxygen. So since there's no oxygen, it's going to be hydro blank ic acid. Now in your notes, I had you put a star next to H2S and H3P. The reason why is there's no way of shortening H2S, okay, of its name. That's sulfur, and they just plug that in instead of shortening it to something smaller, okay? So they just plug in the term sulfur. So I get hydrosulfuric acid. There's no way of really shortening that one. And you wouldn't really know that unless you, sort of experienced seeing this acid over and over and over again and internalized it. But we're going to see it a lot, so make sure that you write down sulfuric. So hydrosulfuric acid. The reason why I put these two next to each other, okay, is because they're named very similarly, but they have two different formulas, okay? H2S does not have an oxygen. That's why it starts with hydro. The next one does. So it's just going to be something ic acid. I have to, in some way, shape, or form, know what SO4 is. SO4 is sulfate. So I have to drop the 8, and I have to plug it into my formula. Just like the one above it, though, they like to use just the term sulfur. So sulfuric acid, not sulfic acid, but sulfuric acid. Okay? The only ones that share this sort of pattern are H2S and H2SO4, and as you can see, the two here at the bottom as well. HF, okay, again, does not have an oxygen, so I would name that hydro something ic acid. What is F? That is fluorine, so I drop the ending, hydrofluoric acid. Okay, hydrofluoric acid. After that, I've got H3P. Again, there is no, make sure that you guys know which one I'm naming. There's no oxygen, so it's going to be hydro somethingic acid. And so we have phosphorus. Okay? We have phos for us. Okay? Hydro somethingic acid. Hydrophosphoric acid. Phosphoric acid. Hydrophosphoric acid. Just like the last one again, I picked these two because they're named so similarly, and yet there's a big difference. Notice that that last one has an oxygen, so that means automatically that it's going to be something-ic acid. The question is, how would we go about naming that one? Okay, so PO4, that is phosphate. Okay, just like before, I have to drop the 8. And so how would I name that? Well, again, unless you saw this a lot, they name that phosphoric acid. Not phosphic acid, but phosphoric acid. So the ones that I just starred are the only ones that kind of have a little bent rule. So make sure you know hydrosulfuric acid is H2S. Sulfuric acid on its own is H2SO4. And then we have hydrophosphoric acid and then just regular phosphoric acid. Okay? So now, can we do the reverse? Can we go from the name to the formula? Okay, that's what we're going to be doing next. Okay, so on your paper, write down these examples. 1, 2, 3, 4, 5, 6. There are 6 examples that we're going to go through. First thing I need to know is, are these acids? Take a look. All of them end in acid, so clearly they are acids. That means I know that they're going to start with an H. What type of ion is that? It's an H plus ion, and then the name itself tells me what the last part is. What is the anion? And I crisscross charges just like before. Okay? Now I have to know whether or not it's going to be just a regular old ion or it's going to be a polyatomic ion. How can I tell? Remember my rules. If it says hydro, that means there's a single ion. If it does not say hydro in front of it, it's one of those polyatomic ions that I needed to memorize. So let's take a look at the first one. We have carbonic acid. Okay, what polyatomic ion had carbonate, sort of in it? Carbonate. Remember, we dropped the ending. We dropped the 8. So carbonic acid, if I'm going to need to crisscross something, I have to know carbonic acid is telling me that I have a carbonate ion. Carbonate. That has a 2- charge, so if I crisscross, I put a 2 here. That means that is H2CO3. I have 2 hydrogens. I have 1 carbonate ion. Next up, hydrochloric acid. Again, I have an H+. Because hydro's there, that must mean that it's just a Cl-. Why? Chlor. If there's only one element on the periodic table that forms a negative ion that has the word chlor in it, and that's chlorine. Okay, the chloride ion. So that just means that's HCl. Acetic acid does not start with hydro, so it must be one of those polyatomic ions that I had to memorize. That was acetate. C2H3O2 with a minus charge. So if I have an H plus and I have that, it balances out. That's HC2H3O2. That's just vinegar, actually. So acetic, acetate. Hydrosulfuric acid has the word hydro in it. That must mean, if it has hydro, I'm looking at a single ion by itself. So I have H plus. There's only one thing on the periodic table that could be, and that is the sulfide ion, sulfur itself. That has a 2-. So if I crisscross my charges, I get H2S. Okay? Hydrobromic acid. Again, I've got H+, I've got Br-. There's only one element that could possibly be, and that's bromine. So I have HBr. Last but not least, I have nitric acid. Notice again, it's going to be one of those ions. Nitrate is NO3-, so that must mean that the formula is HNO3. Okay, hopefully that was a little easier. Now we're going to go on to naming other compounds, so still keep out that paper. Okay, so we did this entire thing. We did all of that. Are they acids? That means that all we have to do is now look at what if it doesn't start with an H? Okay, what if it's not an acid? What if instead it is just a covalent compound? Okay, if it is not an acid, if it does not start with an H like that, then I have to name it by The rule's right here. It says name the first element in the molecule. Use a prefix if the number of atoms is greater than 1. Name the second element. Indicate the number present by using a prefix, the root of the second element, and it has to end in "ide." Now I know that sounds confusing, so I'm going to put up the slide from the notes that we did in order to name these regular old covalent compounds. Okay, hopefully this looks familiar. Okay, we talked about the Greek and Latin prefixes that come in handy when we're naming these covalent compounds. You have to know 1 through 10. Mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. So our rule, name the first nonmetal, and then the second, change the ending to "ide" at the very end. Then we're going to add one of these prefixes, if we have to whichever element in our compound has that number associated with it. Now, one of the things that throws people off is, when do you use mono? Because we know carbon monoxide, when do you use it? Mono can only be applied to the last nonmetal. So if you have a substance that only has one thing to start with, okay, you can't say like mononitrogen dioxide. It's just nitrogen dioxide. If, on the other hand, the last element, okay, only has one, then you do have to add it. You can have nitrogen monoxide. Okay, so let me write down those examples so that you can hopefully visualize them. So I said this first. This is nitrogen dioxide, not mononitrogen dioxide. But this, on the other hand, just NO, that would be nitrogen still monoxide. The only time we add mono is if the last nonmetal has a 1 associated with it. Okay? Now another thing is that the O and the A of the prefixes are dropped when attached to oxide. So we don't say hexaoxide, we say hexoxide. We don't say monooxide, we say monoxide. Okay? So notice that these in particular, like tetra, penta, hexa, hepta, octa, nona, and deca, when attached to oxide, we always say we drop that letter. We drop the A, and we just add oxide at the end, okay? And same thing with like mono. You say monoxide. You don't say monooxide. There's not 2 O's in it like that. That would look a little weird. So now that we know that, let's see if we can do some examples. Okay, so write down these examples. I know they're numbered weird, but we're going to go through the answers right away. So feel free to pause and attempt to do them on your own first. Okay, so the first one, nitrogen dioxide. Nitrogen is just N. Di means 2. And oxide is oxygen, so that means NO2. Chlorine dioxide. Okay, chlorine is Cl. Di means 2, and oxygen, so 2 oxygens. Okay, carbon monoxide. Carbon is C. Mono means 1, so that must mean that I just have 1 oxygen, so that's just CO. Iodine pentafluoride. Iodine is I. Penta is 5, so that must mean I have 5 fluorine associated with it. Okay, dinitrogen trioxide. Di means 2, so I have N2. Trioxide, O3. Tetraphosphorus nonoxide. Okay, tetra means 4, so that means I have 4 phosphorus. And then I have 9 oxygen. That's what no means. Okay, so that means I have O9. Phosphorus triiodide. Okay, phosphorus is just P, iodine, and there's tri, so that means I have 3 of them. So again, go through them. NO2, ClO2, CO, IF5, N2O3, P4O9, PI3. Okay? Now, can we do the reverse? Can we go from just the formula to the actual name itself? That's what we're going to do last. Okay, so last but not least, write down these 5 examples. Yes, I know that they're out of order and there's a lot of blank space, but I picked these ones in particular. So we have P4S5, SBR6, SCl4, CH4, and then NF3. Okay, so can we go in reverse? First things first, are these, covalent compounds? Yes, they only include nonmetals. Another thing, are they acids? None of them start with H, so they can't be acids, so I have to name them using the prefixes that we established. Alright, so I'm going to go in the order that of steps that I sort of outlined before. We're just going to start by writing down the first thing we see. Okay, so the first thing we see is phosphorus. Okay, and then I have to change the ending of the last one to "ide." So I have sulfide. Then I add my prefixes next. So I have 4 P's. That means I have tetraphosphorus. Okay, I have 5 sulfurs, so that would be pentasulfide. So I have tetraphosphorus pentasulfide. Okay, next I have SBR6. So I'm going to start with what I see. I see sulfur. Okay, and then I see bromide. Remember, we have to change the ending to "ide." Okay, so from my starting point, sulfur, I have nothing to add. I don't add mono unless it's the very last element. Okay, bromide, I have 6 of them. So that would be sulfur hexabromide. Okay, so next I have sulfur again. So I have sulfur. And then I have chloride. Have to change the ending to "ide." I only have 1 sulfur. Can't put mono in front of the first thing I see. Cl, I have 4 of them, so I have tetrachloride. Okay, sulfur tetrachloride. Last, on this sort of like chunk, I have CH4, so I have carbon. How do I change the ending of hydrogen? That becomes hydride. Okay, again, can't put mono in front of carbon, but I can put tetra in front of hydride, carbon tetrahydride. Actually, that's known as methane. We won't talk about that until the very end of second semester, though. Okay, but carbon tetrahydride is still a valid name for this compound. Last, I don't know why I said next, I've got a nitrogen, and then I've got a fluoride ion, the end here. What is 3? It's tri. So I have nitrogen trifluoride. So again, to recap, tetraphosphorus pentasulfide, sulfur hexabromide, sulfur tetrachloride, carbon tetrahydride, nitrogen trifluoride. Hopefully that addresses any questions you might have about how to name covalent compounds. If you have any other questions, feel free to ask me in class.